Hi, this is Calvin Cox. It's August 22nd, 2013. It's Thursday, and it is 7:45 p.m. What I wanted to talk about was man-made ice cover over the Arctic. I personally believe it's doable. It would take a lot of planning. And the first year that it was tried, or first winter, would probably be pretty rough. But you would probably learn enough to be able to make a really good go of it the next season. Why do you want to cover the Arctic with ice? Because it moderates temperature around the globe and slows and eventually reverse climate change. If you could cover enough of the Arctic with a 10-foot ice cover, or even 5-foot, I say 10-foot because you're always going to have some cavitation underneath the ice, and you're always going to have ice loss on top of the ice and cavitation from the water going against the ice on the bottom. So you're losing ice from the bottom and the top. And so you need a sufficient amount of ice to have some remain till next winter, when it would freeze up again more solid, and add ice to it. That's why it should be so thick. How would you do this? You start small by making 1/8 mile square, 10-foot thick ice floe to prove the concept. Okay, and this is the idea essentially of the concept, with a starter square in the middle. Okay, you would need 1 to 2 ships. I think probably 2 ships would be preferable. You would have a lot of stuff you need to take up there: people, food, materials, pumps, piping, vehicles to move around on the ice, all kinds of stuff. So it's going to take a lot of equipment and people to do this. Now, one thing I want to show you right now, before I go any further explaining, is I've spent $18 buying dowel rod. Okay, and this dowel rod right here, it's only 1/4-inch dowel rod, but really what I'm showing you here is my concept of what would be inside of the ice. Okay, my belief is that a man-made ice floe that's like 10 feet thick should have about 7 foot of reinforcement on different levels. For instance, these dowels, imagine that they were like 1.5-inch thick bamboo. Okay, and the reason I say bamboo is I've done a little research on bamboo, and bamboo around the world in Asia is used as reinforcing, like rebar and concrete. Obviously, bamboo would not have the strength. It would not have the shear strength of steel, rebar. But nonetheless, bamboo, if reinforced properly, is pretty strong. And if you grow a lot of bamboo, cut it, ship it up to the North Pole, use it to make these like assemblies, these structures to strengthen the ice, that would, and you freeze it in the ice, that would be a form of carbon storage. Now, bamboo can grow really quick. It's unbelievable how fast that stuff can grow. In its growing season, when it's really in full swing, it can grow 20 inches a day. It's unbelievable. Now, it doesn't grow that much all year round. It has its prime growing season when it's going to grow the most. It's the most active, and but it's amazing stuff. Huge amounts of it can be grown pretty quick. You would have a yearly harvest, ship it, use it, and you would use it to reinforce the ice. Now, you might wonder, why in the world would you want to reinforce ice? Well, if you've ever taken, or if you've ever gone on the internet and noticed pictures of the Arctic, you'll oftentimes see where ice floes have collided together and they buckle up, they crack and they buckle up and create these big ice hills. Okay? If you're going to take the time and effort to try and control the weather by building ice floes in the North Pole, the last thing you want to do is have all your efforts get wasted by having floes crash into each other and buckle and, crack apart. You're kind of defeating the purpose. If anything, you want to have the ice floes strengthened with bamboo that's, crisp. Well, I explain this, the assembly, the structure of it in a minute. You want to have it enough bamboo that's in it to strengthen it, so as the ocean moves up and down a little bit, you don't want your whole ice floe cracking that way, and if ice floes end up colliding or coming together, you don't want them to buckle and crack, and you're defeating the whole purpose if that occurs. One of the other major reasons that you want something inside of the ice floe is because people, when these things are built, there's going to be situations where they have to walk out over the ice, and in the spring and in summer that ice is going to get spongy, and you don't want somebody to just fall down through the ice. If you have bamboo reinforcing it, then if someone fell through the spongy ice below, their feet or legs would catch somewhere on bamboo and keep them from going all the way through into the water and drowning below. So it's a safety feature. It's a strengthening feature, and it's a safety feature to keep people safe. Now, what I was thinking about putting a layer, you can see right here is the crisscrossed. I have 4 running this way and 4 running this way. That would be like a horizontal layer. And about every 16 to 18 inches you would have one horizontal layer, then another one, then another one, then another one. I think that works out to about 5 layers for about 7 feet. Now I imagine this is like 7 feet. You only see 3 layers, 1 layer here, 1 layer here, and 1 layer here. So there would need to be 2 more layers, but I can only afford to buy so much dowel and only had so much time to build this thing. So you would assemble horizontal layers and then have pieces running straight through, and that they were connected to each other. And then you would have crisscross pieces. You can see how pieces are running this way and then this way, okay, creating X's on down. That adds more strength. And so you would have X's running this way, and then X's running this way, and then pieces running straight up and down through all the layers. Now, like I said, imagine this is 7 feet thick. There would be 1.5 feet of ice on top, ideally, and 1.5 feet of ice below. So that would leave you about 10 feet. And this much bamboo, it would be good carbon storage, and it would provide strength so the ice floe wouldn't buckle, and it would provide safety so people wouldn't fall through and end up drowning. So, now that said, imagine this is anywhere from 1 inch to, bamboo can get really large. And it might be in the future, maybe large bamboo would be on the top and bottom with smaller bamboo in between. Or it might be one large thick layer of the larger bamboo in the middle with thinner bamboo on the top and bottom. I don't really know. But I think bamboo grows quick. You can get large quantities of it. It's good carbon storage. Meaning if bamboo is grown somewhere and for some reason the crop dies or whatever, if it, the plant dies, it's sitting there, It takes a while, but eventually the carbon in the plant that's in the form of cellulose will eventually oxidize with oxygen in the air and create CO2 again. So it can really be beneficial to store a lot of bamboo frozen in ice floes, and it won't oxidize. It can't. The air can't get to it. Now, let me check my time quick. Okay. Now, one other thing I was thinking of, how would you fasten the bamboo together when you had pieces, crossing each other? I tried to think of something very simple and easy, very straightforward. The bamboo pieces would need to be assembled on a ship in a cargo hold. The top could be opened, and a crane on the ship could let down a line and pick up a section that people had been assembling. After it was all fastened together, I don't know how long it would take to build a section. They could crane out the section and put it over on the ice and wait till it would be moved into place and all the sections tied together, and then start running the piping over top of it to flood it with water, 4 or 6 inches at a time, I'm thinking, and then let that water freeze, and it would freeze around the bamboo, and then you'd be applying water going around this ice floe. Well, actually, if the ice floe were square, you'd probably be applying water on opposite ends, and then moving and applying water here, and let it freeze real good, and eventually you build it up thicker and thicker and thicker, and all the while the water, 6 inches here and another 6 inches later, and eventually you have all this bamboo encased in ice, and it should get very strong. Now, to come back again to the question of how do you tie the bamboo, I was thinking if you just buy cotton duck material, cotton is very plentiful and it's pretty cheap. You could take cotton like this, probably a little longer, and you could roll it up. I'm not sure exactly how large, and you would dip it in like epoxy resin or fiberglass resin, and then you would take it and wrap it around the joint real good. This is just to give you the general idea of what I was thinking about. I'm thinking this probably would be the way it would work, and have something hold it long enough for the epoxy resin to set up. And I think that resin doesn't take too long to set up, maybe a half hour at the most, where you could remove the thing that held it. You could take something that was waxed, real good, and just after you pull the fabric tight, have it clamp around there and hold for a half hour while everybody would keep working and wrapping, and you could easily make a whole day out of that, because you're going to need tons and tons of these structures to make a solid ice floe. This is just my take on it. I don't know it would ever eventually be determined. Okay. There's a lot of aspects to this, so I've been thinking all the little things. How are you going to get this or that done? First of all, what I'm thinking you would start with, let's say 1/8 mile square is 660 feet by 660 feet. Okay, that would be this right here. Okay. And what you would first start with is what you would call the starter square. The starter square would need to be constructed with hardwood 4x4s and clear tubing to conduct a very cold liquid to freeze the seawater. Once square is built, then set up base camp and stock bamboo assemblies until enough seasonal ice occurs around the seasonal ice. The seasonal ice, would be occurring around the starter square. The starter square hopefully could be built up to, 6 or 10 feet thick, really solid, really super cold. 4x4s running this way and that way, an angle and everything, so it's super strong. That's what you need, something that's going to be there. And then, so I'm thinking probably you go to your target area, which would probably be fairly close to shore. Your first time you're doing this, you're learning everything. You don't want to put yourself out in the middle of the ocean. It doesn't make sense. So choose an area that there's not strong currents. I don't know anything about the Arctic area, but there's not strong currents, hopefully very little current at all. And then make sure you try this first time close to shore, meaning, I don't know, you're going to have to pump water from below the ice pack up and out around this area. Well, the starter square, you're also going to need to pump water, but eventually pump water from here. So the water has to be deep enough so it's warm enough, so when you pump it, and you have to pump enough quick enough so it won't freeze in the walls of the pipe and totally screw up your whole operation, which could happen. So I'm guessing you're going to pick your area, take a ship, go out, offload tied pieces of 4x4s and let it float. And you're going to have clear tubing all around those 4x4s. And then you're going to take a very cold liquid and pump it through those tubes, and it's going to freeze up the ice and start the starter square. And then you're going to put more wood at different angles and so on and so forth, and you're going to build that up and ice and everything. And then you're going to move everything out of the ship onto the starter square. Okay, and it's going to be housing and food area and work area and pumps and fuel and emergency boats and all kinds of good stuff that you're going to need, and security people from polar bears and on and on and on. And lighting, because it's going to be dark and you don't want your people walking around without protection, without lighting. You want it to be done in a professional way so people don't get hurt. And then after your starter square is ready, all the while, the water is going to be getting colder and colder and colder, and ice is going to start to form. So you don't want your boat trapped by the starter square. And there's another boat out here that other people are already tying these bamboo structures together, you know, and they're probably already craning some up on their deck and storing them as they're tying more below, and they're learning how to tie and on and on and on. And then, so when you get your starter square done, you move your boat out away back over near the other boat, or over here somewhere. And that allows the boat not to get trapped in the ice next to the starter square, because you want all these assemblies that do end up being around here eventually. You want to put them all the way around and all the way around and keep going and going and going until you get this 660 foot. You might actually make the 660 a little bit smaller. Remember, it's the first time you're doing it. You're just learning. You're trying to get the idea. Is the pumping and the piping going to work? Is the piping insulated enough? How much water can the pumps realistically move? Do they work like we thought they would? All these questions have to be answered the first time. So you're going to move the boat away, and then these people have been tying these assemblies, and they've been moving them onto the ice as the ice will accept it, or put them on the starter block. They've been putting them around here and stacking them up real high. Eventually, after these assemblies are put in place and they're all tied together, then you're going to lay your piping out, and you're going to start pumping 6 inches of water at a time around the whole thing. And or maybe you could do it, just lay assemblies around out, 100 feet from the edge, and just build your ice here first and see how that all goes. Anyway, okay, bamboo prevents ice from buckling, and it prevents people from falling through spongy ice in spring and summer. Okay, let me see. Anyway, the thing is, okay, the thing is basically the dynamic is what you can do when can you move bamboo onto seasonal ice? When will there be enough seasonal ice? My understanding from the research I've done is that basically 2 feet of seasonal ice occurs at the end of the winter when no more ice is going to add to the, it's about 2 feet. Now you would want at least 1 foot of ice that's pretty solid before you start moving bamboo structures out on there. And then when you got at least a foot and a quarter, maybe a foot and a half, because remember that seawater ice probably ain't going to be quite as strong as freshwater ice. So it's a little tricky. So you got to have the bamboo ready, then you got to move it out quickly into place, then you got to put the pipe out real quick, and then you got to start pumping the seawater on there 4 or 6 inches at a time and let it freeze. It might take a couple of days for 4 or 6 inches of seawater put on top of that ice to freeze. It might take longer. It might take a week. I don't know. Because of seawater. Anyway, and then hopefully in one season you could build up at least 6 foot, hopefully 10 foot of your test ice flow. Anyway.